In this video, I will show you how vertex edge graphs work. First of all, let's identify vertices and edges. So as I look at this diagram, these little red dots, they are all vertices. So we have 1, 2, 3, 4, 5, 6. So there are 6 vertices. The edges are the segments connecting the vertices. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 edges. Okay, I guess that was it for number 1. Each vertex of the vertex edge graph represents a city. An edge connecting two vertices indicates that the cities are connected by a highway. Write a matrix that represents the vertex edge graph. So what you do is think about how many vertices you have. Let's see, let's count them up. We have 1, 2, 3, 4, 5. If you have 5 vertices, you are going to need a 5 by 5 matrix. I'm going to cheat and use a table to help keep myself organized, but you don't need a table as long as you keep your rows and columns nice and tidy. But since I'm doing this to teach you guys how to do it, I figure I better do it right. Since this is a matrix, I'm putting these brackets on the outside because that's what you do. So our letters representing our vertices are G, H, I, J, and K. So write them across the top. And we will also write them down the side. So G, H, I, J, and K. So these edges are representing the connections between vertices. All right, it's representing a highway connecting the two cities. So you can't have a highway connecting a city with itself. So I'm going to put a 0 here, saying there's no highway from G to G. And I will put a 0 here, 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 and here for the same reasons. There's no highway connecting city I with city I. All zeros. Now, on the other hand, what about, are there any highways connecting city G with city H? Yes, there's one highway. So I'm going to put a 1 there. Every number we put is going to be duplicated somewhere else, because the highway connecting G to H also connects H to G. It's a two-way street. It's literally a two-way street. So I'm going to put a 1 here as well. These will all be duplicated. What about, is there a highway from G to I? From G to I, there's no highway, so I'll put a 0 there. That means I to G. There'll be a 0 there as well. What about connecting G and J? G and J, no highways, meaning JG, also no highways. What about from G to K? From G to K, 0 highways. That means from K to G, 0 highways. Okay, what about from H to I? From H to I, not only is there one highway, but there are actually 2 highways. There's a straight highway and then the curved highway. So from H to I, I'm going to put a 2 because there are 2 highways connecting those. That means from I to H, I'm going to put a 2 there as well. What about from H to J? From H to J, there is a single highway. That means from J to H, there's a single highway. What about H and K? Let's see. Yes, there's a highway between H and K, just the 1. That means between K and H, there's a highway. What about between I and J? Yes, there's one highway between I and J. That means J to I, also a 1. What about I to K? Oh, there's no highway between I and K, so that's a 0, which means K to I, also 0. What about JK? Yes, there's a single highway between J and K, which means there's also a single highway from K to J. So this matrix represents the vertex edge graph. Notice that in number 3, this vertex edge graph has arrows showing directionality between the various vertices. So that's what makes this a digraph. If you look back at the previous example, notice there are no arrows, there's no directionality. So when you have the arrows of directionality, it's called a digraph. So when we form the matrix for this, we're going to start off the same way in terms of labeling the rows and columns with the vertices. So I will go ahead and put A, B, and C, and then A, B, and C. But this time, when I put a number in a particular row and column, I am going from the row to the column. All right, the row vertex to the column vertex. So for example, is there an arrow from A to A? And actually there is. All right, that's what this loop represents. It's starting at A and then ending back at A. So there is one arrow from A to A. What about from A to B? Yes, there is one arrow from A to B. Okay, so I'll put a 1 there. Now, when we were doing the previous problem, everything was duplicated because these are just connections, not arrows. So a connection from G to H automatically meant a connection from H to G. All right, it was automatically sort of a two-way street. But this is a one-way street. So there is a connection from A to B, but, an arrow from A to B, but there is no arrow from B to A. So we will not automatically duplicate things. So what about from A to C? Yes, there's one arrow from A to C. So I'll put a 1 there. Okay, now here, B to A. Is there an arrow from B to A? No. So I'm going to put a 0 here. What about from B to B? No. If there were, it would be a looping arrow from B back to itself. So no, there's no arrow from B to B. So I'll put a 0 there. What about from B to C? Yes, there is an arrow from B to C, and only one of them. All right, even though there are two connections here, there's only one that goes from B to C. This curving one goes from C to B. That's going to come up later. Okay, now for the final row. From C to A. Is there an arrow from C to A? No. This arrow is from A to C. What about from C to B? Yes, there is one arrow. This curving arrow goes from C to B. What about from C to C? Nope. If there were, it would be a looping arrow like that, and one does not exist. So we'll put a 0 there. So that's how you make a matrix for a digraph. For problem number 4, we are to draw a vertex edge graph to represent the portion of the United States shown here. Let each state be represented by a vertex, then draw an edge between two vertices if the states share a border. Alright, so here are my vertices representing each one of the states. Let's see. Let's start with Alabama. Alabama shares a border with Mississippi, Tennessee, and Georgia. So Alabama shares a border with Mississippi, Tennessee, and Georgia. Okay. How about Mississippi? Mississippi shares a border with Alabama and Tennessee. So we've already got Alabama, so here's the edge representing the shared border with Tennessee. Okay. Let's do Georgia. Georgia shares a border with Alabama, which we already have. It shares a border with Tennessee. All right, so Georgia shares a border with Tennessee. Okay, Georgia also shares a border with North Carolina. Okay, and Georgia shares a border with South Carolina. Okay, how about Mississippi? Mississippi shares a border with Alabama and Tennessee. Okay, so there's the border with Alabama and there's the border with Tennessee. Oh, you know what? We had already done Mississippi. How about North Carolina? North Carolina shares a border with Tennessee, Georgia, and South Carolina. Okay, so North Carolina shares a border with Tennessee, Georgia, and South Carolina. Okay. How about South Carolina? South Carolina shares a border with North Carolina and Georgia. So there's North Carolina and there's Georgia. Okay. How about Tennessee? Tennessee shares a border with Mississippi, Alabama, Georgia, and North Carolina. Okay, so that's 4. And I see I've got 1, 2, 3, 4 connections. All right, so that's it. This is our vertex edge graph. So we are also to create a matrix representing that same information. Let's start by putting zeros down the diagonal because it does not make sense for a state to share a border with itself. So that's what these zeros represent. No state can share a border with itself. Now, notice that every entry that I record will have a duplicate entry on the opposite diagonal. So, for example, let's see. Does Alabama share a border with Georgia? Yes, it does. Well, that automatically means that Georgia shares a border with Alabama, so we duplicate that. That's going to happen every time. Does Alabama share a border with Mississippi? Yes, it does. That means Mississippi, Alabama as well. Does Alabama share a border with North Carolina? Alabama, North Carolina. No, it doesn't. That means North Carolina, Alabama. That's a 0 as well. Does Alabama share a border with South Carolina? It does not. So that means a 0 here and here. Does Alabama share a border with Tennessee? Yes, it does. So that means here and here. Does Georgia share a border with Mississippi? No, it does not. Okay, which means a 0 here and here. Does Georgia share a border with North Carolina? It does. That means a 1 here and here. Does Georgia share a border with South Carolina? It does. So that means a 1 here and here. Does Georgia share a border with Tennessee? It does. That means a 1 here and here. Okay, does Mississippi share a border with North Carolina? Nope. So that means a 0 here and here. Does Mississippi share a border with South Carolina? No. That means a 0 here and here. Does Mississippi share a border with Tennessee? Yes. Yes, it does. So that means a 1 here and here. Okay, does North Carolina share a border with South Carolina? Why, yes, it does. So that means a 1 here and here. Does North Carolina share a border with Tennessee? Yes, it does. That means a 1 here and here. And does South Carolina share a border with Tennessee? Nope, it does not. So that means a 0 here and here. Alright, so we were to call this first matrix matrix S. Now we're to make a new matrix called S cubed. Alright, well, not just called S cubed. We are to take matrix S and cube it and see what we get. So I am going to type matrix S into my calculator. So I'm going to go second matrix to get to the matrix area. I don't think this actually goes up to S. As far as it goes is J, so I might as well just put it in matrix A. So I'm going to go to the edit menu, and this is a 6 by 6 matrix, so I will change the dimensions to 6 by 6, and I'm just going to start typing this in like 0 1 1 0 0 1 0 1 1 0 0 1. Boom. And I won't bore you by making you watch me type in the rest of this. I'll do that off camera. Alright, so here I've typed it all in. So I'm going to quit my way out of this by hitting second mode to quit. I'm going to go back to the matrix area, second matrix. I'll just hit enter to select matrix A. Now I want to cube this, so I'm going to use the caret and put a 3. So this will be the cube. And bam! This is the matrix that I get. Alright, so here's a copy of matrix S cubed. So this matrix represents the number of ways you can travel from one state to another, traveling over exactly 3 edges of your vertex edge graph. For example, this 2 connecting Mississippi to Mississippi means that there are 2 ways that I can go from Mississippi to Mississippi on this vertex edge graph while using 3 edges. So for example, maybe I'll use my highlighter to show this. Okay, so here's one way. I could go from Mississippi to Alabama to Tennessee back to Mississippi. So that's Mississippi back to Mississippi using 3 edges. Alright, now here's another similar but different path. I could go from Mississippi to Tennessee to Alabama and then back to Mississippi. Alright, that's a second way to get from Mississippi back to Mississippi using 3 edges. Okay, so that's what these numbers mean. So how many paths are there from Georgia to North Carolina using 3 edges? Let's see, Georgia to North Carolina, that's 7. There are 7 paths from Georgia to North Carolina using 3 edges. Alright, where can we find this in the matrix? Well, there are 2 places. We can look in row 2, column 4. So let's see, row 2, column 4. Or of course, row 4, column 2 has the same information. One more question. How many paths are there from Georgia to North Carolina if you travel over 5 edges? Well, if you want to use 5 edges, you need to consult the matrix S to the 5th power. So let's find that matrix. We already have the matrix S in the calculator, so that's S to the 3rd power. I can just clear that out. So to get S to the 5th power, I will just go to the matrix area, second matrix, hit enter because matrix A, use my little caret, and this time we'll do the 5th power. Boom. Okay, so here is a to the 5th power. Looks like it didn't quite fit. Alright, some of it is off screen. However, Georgia to North Carolina, we only need the first 4 columns anyway, so let's make it work. Alright, so here's a partial copy of s to the 5th power. So from Georgia to North Carolina, using 5 edges, we are clearly talking about this. Boom! 67. Or we could look here. Same thing. Alright, either way, there are 67 ways to go from Georgia to North Carolina on our vertex edge graph using 5 edges. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.